Welcome to Chemistry 101, Chapter 2, Selected Problems. Okay, so we got a periodic table. What is the atomic number for each of the following elements? So hydrogen is a diatomic. So hydrogen is H, and it's found in nature is H2. It's one of the 7 diatomics. And so when it's asking just for the atomic number, it's just talking about the atom hydrogen. So we look here and we see that hydrogen is right here, and it is element number 1. So atomic number is the number of protons. I think of it as like the social security number. Your number identifies you. Well, the number of protons is the atomic number, and that identifies the element. So if I say, what is element number 1? Which element has a proton count of 1? It's hydrogen. It always will be hydrogen. Okay, oxygen. Well, we find oxygen here. Here's oxygen. And what number on the periodic table is oxygen? Yeah, so oxygen is 8. And that's the number of protons, but it's also called the atomic number. It's just an AKA. This other number here, we'll talk about it, is the average atomic mass. And that is something different. Silver, you need to start learning probably elements through 36. And so silver is Ag. And so Ag is right here. And that's silver, and that's number 47. So 47 protons. Okay, so now we have, these are our subatomic particles. Subatomic particles include 3 of them. There's the protons, the neutrons, and the electrons. And so you're seeing these problems, these elements written like this in your book, and that top number is the mass number. And this bottom number is the atomic number. And the atomic number, a lot of times we don't have to even put it because this is argon. And argon is Ar, it is element number 36. Or not 36, it's 18. So here's 18. So you see the element 18 is argon. And so you don't even need to put that number. It's kind of like redundant. So then when you see something like this with 36, this is the mass number. And you'll want to memorize this. Mass equals protons plus neutrons. And so you're already given 2 numbers here. You're given 36 for the mass, and your protons are 18. So how would you solve for n? You would do 36 minus 18 equals n. And I will get my calculator out. 36 minus 18. So the number of neutrons is 18. And so it's asking for atomic number, which is the number of protons. So in this case, it'd be 18. The neutron number is 18. And these 2 equal the mass. And as for the mass number, and the mass number here is 36. Now notice 36 is different than the number given here. And the number given there is like 39.946. That is the average atomic mass, which is different than when you have this here. This is of a single isotope. And so you can have several isotopes that come together and average to get the number you see on the periodic table. Okay, so argon 38, obviously that's argon. So that is another isotope, and it has a mass of 38. So argon 38 has the same number of protons as the other argon, which is 18, but they have different number of neutrons because the mass is different. So the mass is 38 equals 18 plus n, And now we do 38 minus 18, and that gives us 20. So they have different neutrons. And these two are isotopes. Isotopes have the same number of proton. So you see the same number of proton, 18 and 18, but they have different numbers of neutrons. And that's what an isotope is. Oh, we have another isotope here. We have argon 40. So the number of protons, once again, is 18, because that's argon. The neutrons are going to be different. So now the mass is 40 equals 18 plus N. So what is 40 minus 18? 22. So that has, and then of course the mass equals 40 here. And the mass of this one equaled 38. Iron 56. Where is iron? Iron Fe. Right here. And so iron has a number of protons equal to 26, and its mass is 56. So 56 equals 26 plus N, neutrons plus protons. So what's 56 minus 26? 30. So the number of neutrons is 30. We have potassium 39. Potassium 39 is over here. And so we have protons equals 19. The mass is 39 equals 19 plus N. So 39 minus 19 is 20. So neutrons equals 20 and the mass equals 39. Copper 65. Not CO, that's cobalt. This is copper. Copper is proton number 29, and its mass is 65, so 29 plus N, neutrons equal 65 minus 29 equals 36. All right, so now we want to fill in the chart below. So the mass here is 23. And Na is sodium, so we see sodium here. So number of protons is 11. This is atomic number. And then these are neutral, so the number of protons, proton is a positive. And so the electron is a negative one, okay? So this would be 11 electrons if it's neutral. So this is neutral. So the number of protons, the positive, have to equal electrons. And then neutrons would be the mass equals protons plus neutrons. So 23 equals 11 protons plus N. So 23 minus 11 is 12. Okay, let's do another one. Here we don't know what the symbol is, but we have 25 protons. So this is going to be manganese. And I don't know what the mass is yet. The mass is protons plus neutrons. And so we have 25 protons plus 31 neutrons. So the mass is going to be 25 plus 31. So this is going to be dash 56 for the mass. And then this is neutral, so we're going to have to give it the same number of electrons. All right, so we're going to assume that this next one's neutral. If it has 8 electrons, we're going to assume that it's 8 protons. And so we're going to look for 8. 8 is oxygen. And then the mass is going to be we're going to add the protons plus the neutrons together, which will give us 18. So that's O18. Okay, F19, fluorine. Fluorine is here. Proton count 9. The mass is 19, so 19 equals 9 plus N. So 19 minus 9 is 10, and it's neutral, so it gets 9 electrons. The electrons have to equal protons when it's neutral. All right, the next one is chlorine, and it is not neutral. You see if you have a charge, it's going to be there. That's a -1. So a -1. Well, before we do that, let's look at Cl on the periodic table, and we see it's element number 17. So that means there's 17 positive charges. And so if it has one extra electron, it'd have to have 18 electrons, because 17 protons and 17 electrons would make it neutral. And so if you had an extra electron, now you have a -1 charge. You got to have, so if you have a -1, you're going to have one more electron than proton. So if you have 17 protons, you need more 18 electrons. Okay, now 37 is the mass. You see 37. So 37 is the mass, and the proton is 17 plus N. So what is 37 minus 17? It is 20. Electrons have no mass. All right, let's go to the next one. The next one is calcium. Let's find its proton number, atomic number. Proton number is 20, and it has a +2 charge. So it has 2 more protons than electrons. So if it has 20 protons, then it needs to have 18 electrons. So that gives it 2 more protons and electrons. The mass is 40, so 40 equals 20 plus N, and so that gives you 20 neutrons. All right, so the next one we have is atomic number 12. So 12 is magnesium, and its mass is 12 plus 13 is 25, and it has a charge. So I tell you what, I'm going to write it like this. Magnesium, and what do we say it was 25, so I'm going to put 25 up there. So I have place for the charge. Okay, we have 2 more protons than electrons. So that means it's a +2 charge. All right, identify which of the elements, bromine, potassium, magnesium, aluminum, manganese, and argon, can be classified as the following. So hopefully you have shaded in your periodic table. We will make a legend now. So let's see. Okay, so this group is the alkali metals. This group is the alkaline earth metals, and I just think of it as the longer, bigger word would be the second column. These are all metals, by the way. So I'll show you where, so these are your metalloids here. There's like a little stair step here. What's a metalloid? A metalloid is partially metal and partial non-metal. So this is the crossover. So that means these here on this part of the periodic table are your non-metals. These are your non-metals. Okay, so those are non-metals. 2/3 of the periodic table are metals. And when we start learning these things, metals always form positive charges. They don't form negative charges. And you'll be writing them first whenever you're writing chemical symbols. Okay, so we have alkali metal, halogens. The halogens are, these are your halogens. And hydrogen is not included. Okay, so these are your halogens. Your transition metals. Okay, these are your transition metals. They're this B. All this here is transition metals. Transition metals. And then noble gas would be here. These are your noble gas. These are your main group. Main group. So now we're going to find these different elements and we'll classify them. So bromine is here, and that would be a halogen. So we're going to put bromine there. Potassium is here. That would be an alkali metal. Magnesium is here, which would be an alkaline earth metal. Aluminum is here, and that's going to be a main group. Okay, so it's going to be classified as a main group element, aluminum. Manganese, Mn, manganese, is a transition metal. And then argon is a noble gas. In which group of the periodic table do all the elements occur as diatomics? So in which group? So periods go across. And groups go down. And I told you that the diatomics, there's 7. And hydrogen forms a diatomic. And then you start with nitrogen and you make the 7. So these are your diatomics. 1, 2, 3, 4, 5, 6, 7. And so which group? I don't include AT in there. I think it's just huge. Anyway, this would be the halogens. And that is 7A. Identify the groups of the periodic table in which all the elements form ions of the charges. Okay, so I told you that 2/3 of your periodic table are metals. And metals form positive charges. Because when you form with a compound, you got to get it neutral. That's why compounds form stuff like salt. Okay, so like sodium chloride. That is something that is thermodynamically feasible, you know, table salt. And what happens is the sodium is a +1, the Cl is a -1, and then the positives first are first. You always be the positives first. And these are nonmetals. Nonmetals form negatives if they're going to form a charge. And they come together and they have to sum to 0. And so that's how compounds, and this is sodium chloride. And so what charges? Well, the first one, the +1 here, the metals, like I said, here's your nonmetals. So these are your nonmetals. And these will form negative charges in a compound. So everything else All of these are metals, and they form positive charges when they're in a compound. All right, so group 1 is a +1. So what are those? The alkali metals. Group 2 is a +2, and these form +2. So these are alkaline earth metals. The next one are negative. So cations are positive. If you like cats, then that's positive, the cation. If you don't like onions, you think of an onion, negative, it's an anion. That's how you can memorize it. But anyway, so the -1 anions, these are both ions. See, cation and anion. Okay, so -1, that would be the halogens. So your halogens are -1. Your noble gases do not form charges. They're noble. They do not interact. So these are your halogens. And then the -2 are here, and they would be group 6A, form the -2. Okay, something else you need to do is be able to do the average atomic mass calculation. And that is the mass number you see in the periodic table. And it will have lots of numbers after it. Like carbon is 12.011. Hydrogen is 1.008. But when you did your mass for your isotopes, when you did like carbon 12, because you can have carbon 14, this mass number was atomic mass unit. And so these have, protons are 6, right? But here the neutron is 6, and here the neutron is 8. So these are isotopes. They have the same, something similar, isotope. Same number of proton, but they have different number of neutrons. And since protons plus neutrons make up your mass, they have different masses. But we like to have one mass to represent carbon or hydrogen. Hydrogen has H1, H2, and H3. Tritium is actually used in the like the nuclear power plants, and these average to the average atomic mass. So there's a formula to calculate this. Average atomic mass equals the AMU times the percent abundance of one isotope plus AMU times percent abundance of the next isotopes, and then you just add them all up. So let's figure out what the average atomic mass is here. So here you would take 21.995 AMU times, now you won't want to put 75% in there, you want to move the decimal 2 places, times 0.75. And then we're going to plus that, and we're going to add the next one, 19.996 AMU times 0.25. Now we're going to get your calculator out, and you're going to do 21.995 times 0.75. That gives us a number 16.49625. And then we're going to do 19.996 times 0.25, and that's going to give you 4.999. And then we add them together, 16.49625. And so the average atomic mass equals 21.495. Now, does that make sense? Well, the number, the average atomic mass, should be closer to 21.95 because it's 75% abundant. So it's more abundant. So is that closer to 21 or 19.9? So, and you can add up lots of isotopes. Like hydrogen has 3. I think carbon has 3. You got carbon 13. Okay, that concludes the selected problems for Chapter 2.